P.4 Geometry. In this section, I'm just reviewing simple area formulas of squares, triangles, trapezoids, and circles. This is material that you do need for calculus. So the first four examples are set up in the same manner. We're going to find the area, and A is just a regular shape, but then B is the calculus version of how this question would be asked. So here A is a square, and if I want to find the area of a square, it's just length times width. So of course, the area is just 12 times 12, which is 144. And then in this class, it is really important to remember units. So this is centimeters and area is squared. This is actually units are about a point on the FRQs. Now B is the same idea. It's not a square, it's a rectangle, but the area is the same. The formula for area is the same. But see, if you look, this is actually a graph of an equation. It's y equals 4. Y equals 4 is a horizontal line. But instead of looking at the entire line, which would probably go about like this, instead of looking at the whole line, we're just focusing on a piece of it, from x equals 1 to x equals 3. So we're only looking at that section, and then that piece of the line, when we look at that section from the line to the x-axis, there is an area underneath this line, and that is the shaded pink part. And that's what we're looking for. We're looking for the area underneath this line from x equals 1 to x equals 3. So this is usually referred to as the area under the curve, although this is not a curve, it's just a straight line. But the idea is it's the area underneath a graph, whatever area it makes with the x-axis. And of course, the x's, that would be my width, so it would be 2 wide. And then my length is how tall this graph is, which is just 4 units up. So of course the area is 2 times 4, so it is 8. And there are normally not any units when it's actually in a graph. But this is usually the answer to a problem. So to continue with the pattern, A is just a rectangle. We would find the area of the rectangle. So 1/2 base times height, or length times width. I'm just going to use both. So the 10 centimeters, that would be the base. That's the length of the bottom part of the triangle. And then the 12 is how tall this triangle is, so that's the height. And then so if I want to find the area, it would just be 1/2 times 10 times 12. And let's see, half of 10 is 5. 5 times 12 is 60. And this is once again centimeters squared. Cannot forget my units. Now B is the same exact thing, just that if you look, the graph is being made by absolute value, right? This is an absolute value, but the negative means that it is upside down, and then the 4 means 4 units up. And then they're focusing on the domain of -4 to +4, right? Those are my x values, my highest and my lowest. And so they're only looking at that piece of the graph. But yes, the graph does go on. It keeps going, right? So we're only finding the area in between the two straight lines and all the way up to the x-axis. Once again, area under the curve, with these are straight lines. And it is, what shape is it? It's a triangle, so find the area of the triangle. Okay, this is important in this class, and it is supposed to be simple, and I certainly hope that you're like, OMG, I can do this. Calculus is not that bad. Okay, so my height, right? So all of this right here is 4. And then the base, the length of the base, or how long the base is. Let's see, there's 4 to each side, so it's 8. So the area formula still 1/2 base times height. So it's 1/2 times 8 times 4. And then half of 8 is 4. And then 4 times 4 is 16. And once again, there are no units. Example 3, we're finding the area of trapezoids. So A is just a regular old trapezoid, but I found one that was sideways. The formula, I don't know if you remember it, but it's 1/2 times the height times base 1 plus base 2. So whatever quantity we get from base 1 and base 2, after we add them, we multiply that with the 1/2 h. So height is how tall the trapezoid is. And this one, like I said, is sideways. But this right here is the height. And then these sides are going to be the bases. It does not matter which one is base 1 or which one's base 2. That's never been important. So in actually finding the area, it's just 1/2 times the height. This trapezoid is 8 meters tall times the bases added together. So 3 plus 10. So half of 8 is 4. 3 plus 10 is 13. So then it would be 40 plus 12. So that's 52. And then this is meters. And area is always squared. So B is the same idea. You will have to find the area of trapezoids on the coordinate grid. And as you can see, the graph is just x plus 2. It's a straight line. It would, just normally look like this, right? But we're only interested in the area right underneath that line from 0 all the way to 3. And that's what makes it the trapezoid. So we want this and this and that, right? And this makes my trapezoid. So how tall is my trapezoid? So it is 3 units tall. Okay, this is sideways just like A. And then the bases, so let's do it. Here's my base and here's another base. Okay, for trapezoids, the parallel sides are always the bases. If you don't remember that, then you need to write yourself a note. Parallel sides are the bases. Okay. So let's see. This one is 2 units long, and then the other is 5 units long. And so area 1/2 times the height, which is 3, times the bases added together. Half of 3 is 1.5. So I'm just going to do 3/2. Please, I encourage you to use fractions. They are friendlier. Very few, with very few occasions are decimals preferable. I mean, 3/2 is a perfectly good number. 2 plus 5 is 7. So now this is 3/2 times 7. And because I left it as a fraction, I can do 3 times 7, which is 21, divided by 2. And then hopefully you could do this in your brain, but you don't have to. In this class, it is not necessary to simplify. This is a viable answer. I do not need to know that this is 10.5. Okay? Moving on to circles. Here for A, we're finding the area, and this is just one whole entire circle. And the formula for circle is pi r squared. Okay, all you need is a radius, and here's my radius. The radius is half of the diameter. And if the radius is 7, then all I got to do is pi times 7 squared, which is 49 pi. And then this is in feet, and area is squared. Now you must be wondering, do we have to do anything with the pi? No, we don't. This is also a viable answer. Must you at some point plug in to get a decimal? If it's a multiple choice answer and all the answers are decimals, then yes, you're probably going to need a decimal. If this is an FRQ, this is perfectly fine. But if you were to get a decimal, please always round to 3 decimal places. And if you're afraid that you might mess that up, do 4. If you do 4, then you're guaranteed the right answer because they accept rounded to 3 decimal places, or if you take the number and you cut it off at 3 decimal places. It does not have to be rounded, but it's a good rule if you give yourself 4 decimal places. All right, B. Now, B is the version that we're going to have to find the area of. It's not an entire circle. It is a semicircle. And that equation is what it looks like when it's a semicircle. Hopefully, you have retained some information from Algebra 2 and Pre-Calculus when you did circles, or even geometry, because geometry students actually do learn the formula. the standard equation of a circle looks like this. So if, let's say, um, I want it to be an actual function. See, circles don't pass the vertical line test, right? If this were actually continued, now we're to draw a vertical line, oh look, it hits it twice. You know, circles are not functions. So in this class we try to deal with functions, and a circle wouldn't work. So we use half circles, semicircles, because they're functions. Because without the bottom part, they are actually functions. So in order to have a function, I would need y equals something. And that's all this is. Y equals that. So let me manipulate that equation so that you could see how it is the equation of a circle. So y equals the square root of 4 minus x squared. I'm trying to get it back to look like this. So let's see, I gotta get rid of the square root. And how do we get rid of square roots? Well, let's square this baby. But in algebra and all of math, whatever you do to one side of the equation, you have to do to both. So now I have y squared equals 4 minus x squared. Let me move the x over. So I'm going to add x squared to both sides. So now I have x squared plus y squared equals 4. Well, look, the standard form of a circle. Okay? I need you to be able to recognize this as being a semicircle. It is very helpful when you do. Okay, so let's go back, and I'm going to actually find the area now. Okay, so area is pi r squared, but that's the area formula for an entire circle. We don't have an entire circle, we only have half. So I'm going to make that edit by multiplying this by 1/2. Now you could divide by 2, either or. They both work the same way. And all we need is the radius, and the radius is the measurement from the center of the circle to the edge, and this radius is a 2. So 1/2 times pi times r, which is 2 squared. There we go. And then, okay, 2 squared is 4, half of 4 is 2, so 2 pi. And there's my viable answer. Which, of course, if necessary, you can make into a decimal. Just remember to round your decimal to 3 decimal places. Alrighty, we've come to the end. Example 5, estimate the area of the shaded region. So the keyword here is estimate. This is going to be an estimation, so it does not have to be perfect. You can look at this geometrically, of course, which is that every single one of these little, I can't get, there you go. Every single one of these is just a square. So you find the area of one of them, and then figure out how many of them you have. Now, some of these are not whole squares. No big deal. Let's see. Let's count. Here's 1, 2, 3. Now I'm counting the whole ones first. So 4, 5, and 6. And then 7, and then 8, and then 9, and then 10. Now I have 10 whole squares, right? Okay. You must be thinking, are we really just counting squares? And yes, we are. I need you to be able to find the area of the shaded regions underneath curves. This actually happens to be a curve. As you can see, we're focusing from 1 to 5, and these are usually the answers to questions like, what is the total distance traveled? Or what is the total amount of water leaking out of the water pipe? Certain things like that. And sometimes they make you think outside the box, so they don't give you an equation, they just give you information in a graph. And you have to be able to analyze and read the graph, and that's what we're doing right now. We're trying to figure out how much area is in the shaded region, even though it is a weird shape. So we do it by cutting it up into squares. And it's going to be a rough estimate, which is fine. Okay, so we have 10 whole squares. So now I'm going to make the executive decision of saying that these two make one more. Okay? And then these two look like they make another one. I hope you see what I'm doing here. And then finally, these two. If I put those suckers together, they should make one entire circle. I mean square. Oops. Now, could there possibly be some extra? Sure. But this is an estimate. And that, as I said before, that's the key word. So now, what is the area? 13 units. Yeah, there aren't any units here, but I just feel better saying units. And this is an estimate. You could say that it is approximately 13. That's supposed to be an approximate symbol, but it doesn't really look like it. Let's see. Well, let me redo that. Okay.